right, well, welcome. Today we're going to talk about how relationships are hard and going through some of the NoSQL data modeling, and get some of my thoughts and ideas on modeling your data in the NoSQL world. I titled this talk, Relationships Are Hard, because if anyone is in a relationship like me, maybe you're married, maybe you have a significant other, you're dealing with friends, you're dealing with coworkers, you're in a family. You have learned throughout life that relationships can be hard. It's kind of funny, developers are kind of maybe known for hiding in their basement, trying to avoid relationships, but I think as a skill, it's one of the best things we can learn is to deal with relationships. But all relationships take work. They take some energy. You have to put something into them in order to get something good out of them. So I think that relates very much to our world of programming and databases. And some of the new style databases like Couchbase that are out there that make dealing with relationships maybe easier or different, or maybe they help you avoid dealing with relationships. Because just like in the real world, the relationships in relational databases cause some issues. They can bring some pain if you don't manage them and deal with them well. So a little bit of what we won't be covering today. We won't talk about why Couchbase is the cat's pajamas, but you're here at a Couchbase conference. You obviously already know that is the go-to standard for NoSQL document databases. It's pretty kick butt at that. We won't talk about why you should never use a relational database again, because there are places for that, and we'll talk more about that later on. We won't look at map, reduce, and views and other query options in NoSQL. And we won't prove the theory of relativity. I don't think we'll have time for that. But what we will talk about is where NoSQL came from, some database theory, when it's good and not good to use NoSQL, a few key patterns. So when you're keying data in a NoSQL world, what you should use for that, or some ideas anyway. A few data model patterns. So like when should you embed data or link data. So we'll look at that, and some samples and ideas of when to use both as we go through. So if you want to leave now, this isn't what you thought it would be. Now you know what we're going through, and I won't waste any more time. Otherwise, we'll keep going, and you will learn. So who am I? My name's Kurt Gratz. I'm a husband to a beautiful wife, dad to 3 beautiful children. I coach cross country and track at our local high school. It's kind of what I do for fun. I'm also the co-owner of Computer Know-How. We're a small technology firm based out of sunny southern Wisconsin. I like to run for fun, even though maybe my weight doesn't agree with that, but I do run a lot. And I pride myself on being a polyglot. I like to use the right tool for the right job at the right time. So let's get into it. The first thing that I want to talk about is where NoSQL came from, or what does it mean? Martin Fowler did a talk, and he wrote a book on NoSQL, and he was like, if I'm going to write a book on this, I need to know what it means. And really, all NoSQL, the whole concept of it came from just a meetup of some people trying to solve problems that they were having with all the different database options that were out there at the time. And then from that meeting, they coined the NoSQL hashtag. So Johan Åkesson made this hashtag NoSQL, and it just kind of became a buzzword around the industry. And really, kind of in the early 2010 to 2015, it was a huge buzzword. It's like, oh, if you're not using NoSQL, what are you doing? But nobody really knew what it meant. So let's take a little bit of time and define what exactly does it mean to have a NoSQL database. So some standard characteristics of a NoSQL database are that they're non-relational, that it's open source, or at least some of them are open source, or like Couchbase, where they have like a professional services backing up an open source option. They're generally cluster friendly as a rule. They're built in the 21st century, and for the most part, they tend to be schemaless, or at least have an implied schema when you're dealing with a NoSQL database. Some standard types of NoSQL databases that are out there. There's your straight up key value databases like Memcache or Redis. There's document databases like Couchbase is. There's a column database like Cassandra or HBase, and there's graph NoSQL database like Neo4j and Infograph. There's a little bit of a gray line between what's a key value database and what's a document database. And if the key value provides enough metadata, is it really a document database? Or if the document database really just stores a key, is it really a key value? So there's a little bit of gray area there, but generally NoSQL databases fall into one of these types of databases. So before we move too far down this, I want to talk a little bit about some database theory. And this might be new to you, and it might not. If it's not, I apologize, but I think it's important level set that we understand a few things around like the database industry to help us set what we're going to use these NoSQL databases for. So the first thing that I want to talk about from a database theory standpoint is the CAP theorem. So the CAP theorem says that your data can be consistent, available, and partition tolerance, but you only get to pick two. So consistency deals with all the nodes seeing the same data at the same time. So if you're in a multi-node environment, all the nodes are going to have that same data on. If that is a possibility, then it's said to be consistent. Availability means that no matter what, you're going to get a response, whether that request succeeded or failed. And then the partition tolerance deals with whether the system can continue to operate if there is a loss of a node or part of, or maybe a network outage, etc. So as you're dealing with this, you can have databases that are partition tolerant and available, but then they won't be consistent. There won't be a guaranteed consistency between them. You'll have databases that can be consistent and available, but then they won't be partition tolerant if a node goes down. You can have databases that are consistent and partition tolerant, but then they won't necessarily always be available because either the whole system's up or the whole system's down. So some examples in each leg there. So typically your standard relational databases, MySQL, Postgres, MS SQL, et cetera, are consistent and available. And then your NoSQL databases kind of fall into one of the other legs. And you'll notice that Couchbase is pretty awesome because it can be either consistent and partition tolerant or available and partition tolerant. It's kind of dependent on your configuration and how you set up your cluster. So that's a nice thing about Couchbase. So that's a CAP theorem. As we're designing our data and we're thinking about our system and we're choosing how to persist data, we need to think about CAP theorem and what matters to us in those legs of the triangle. The next thing I want to talk about is this concept of ACID. ACID in database theory talks about, it's an acronym for making sure that data kind of is in different states properly throughout its life. So the first thing it deals with is atomicity. So in other words, it's all or nothing. This is the concept of a transaction. So imagine the classic example, we're a banking system and we have Tom and Bill, and Tom is going to give some money to Bill. So we're taking Tom's data and we're subtracting $50 from Tom and we're adding $50 to Bill. We wrap that in a transaction because we don't want Bill's money to go down and Tom's money to go up unless all of that happens. Because what happens without a transaction is if we deduct the money from Bill and we don't give it to Tom, all of a sudden Bill's balance goes down and now this money is lost and poof and gone everywhere. So that's the idea that there's this guarantee of all or nothing, and that's built into most relational databases, and it may or may not be built into your NoSQL database. What's cool about Couchbase, actually in the latest version, they have multi-document transaction support, so they're working towards atomicity. What's nice about that too is it's a choice. You don't have to make all of your documents have to deal with the full transaction unless your use case requires it. The next is consistency. Data is never violated. So this deals with the concept of things like foreign key constraints, data validation. So when you're building in a traditional MySQL database, you're defining your schema and you're saying that you're making a column called amount, and you're going to give it a type of money, and that only money is going to go into that column. And you might have another type or another column that's, the date of the transaction, and that's going to be a type of date. And as you're inserting into that database, it's going to guarantee that you will never have data in that date field that's not a date, and in that money field that's not a money type. In most NoSQL databases, you can do whatever you want with your data. That's more on the application side to decide how to do that validation and to do it before it ever gets to the database. Now, obviously, you're trading then maybe some consistency for some speed, as we'll talk more as we go through this presentation. The next we have isolation. So this is the concept that a data must be complete and in isolation from other data before it's finished. So this is the concept of locks in a traditional database. And your NoSQL database, if you choose Couchbase, will have the option for locks for you, both pessimistic and optimistic locks. And Couchbase, it's pretty cool that they have a pessimistic lock system. They call it a CAS. That gets applied, and it basically locks that document, so only one writer can ever update that document at one time, and it'll alert when the next person comes to get that. It'll say, you know, that doc's locked. It'll wait, give it the doc when it becomes unlocked, or it'll time out if it doesn't unlock in time, and you can configure all that. But this may or may not be a part of the NoSQL database that you choose, so you might give up some of that ACID isolation if your NoSQL database doesn't do that, or if you don't configure it for it. But again, Couchbase is pretty awesome because it gives you the best of both worlds. You can, and the use cases you don't care about isolation, you can just do a get, and if you care about it in the SDKs, you can do a get and lock. So it gives you both options. And the last part of our acronym is D for durability. And that's that the state is persisted when the operation finishes. So there are many NoSQL databases that will not persist things to disk right away. They'll wait. So if there's a power outage or the disk, you know, the server goes down or it can't write to disk, that data is gone. So there's this idea that in ACID databases, you must meet the durability test. It must be written to disk and persisted and be there forever before an operation finishes. Again, what's cool about Couchbase, this is something you can choose to do or not do, whether you want to wait till the read's complete. You wanted to wait till the read's complete on 3 nodes. It lets you do that based on your configuration or not do it. And again, now up to you as the developer and the architect to choose which use case is right for you. What that lets us do is to allow NoSQL to be web scale. And there's a funny meme out there that, you know, we joke about NoSQL being web scale, but MS SQL runs a whole bunch of databases that deal with millions and millions of transactions at a time. So we'll talk more about the right tool for the right job later, but NoSQL can handle a lot of data and do it very quickly because it's giving up on some of those ACID principles. So in a NoSQL database world, they came up with a different acronym. I think it's funny because they mirrored the ACID acronym with base. That means it's basically available. It's up most of the time. But you're giving up that guarantee of availability for speed. You have soft state, so things might not be the most recent version that you're pulling of the database because again, we're not dealing with that isolation or that durability. It might be getting an outdated version, but that's okay because we'll have eventual consistency. So this concept that, you know, we wrote it in one node and eventually that'll go to the rest of the cluster as time goes on. So those are kind of the trade-offs. We don't have full ACID support maybe in our database, or if we do, you know, we're configuring it in such a way to get that ACID. But what we're giving up for that, or to get that is, what we're getting for that, sorry, is to get more speed out of our database. So there's just the trade-offs between acids and bases, and you, as a developer or architect, you get to kind of make some choices that you never got to make in a traditional relational database world. The next thing I want to talk about is how your data modeling might look a little different in a NoSQL database world versus your relational database world. If you remember from your computer science classes or anything, the concept of normalization. So it used to be that we always wanted data as normalized as possible, and we push towards the third normal form, getting data out there that way as much as we can, because this caused a lot less data duplication, many less storage states. You had very high consistency and data integrity when you did it this way. it was very easy to query this way. Now, maybe not quick, but easy to query this way. And the updates were very easy this way. So this might look very familiar to you. We have our normalized data. So here we're storing users, and users have groups and statuses. And we're only storing the status in the status table and the groups in the group table. And if we wanted to update the active stat or the inactive status to call it closed, maybe we just have to update that one row in the table in the database, and we're on. It's easy to update that. This is very normalized. We can query against it and get those, but we have now relationships that we have to deal with, all these joins that can potentially slow down our system. So in a NoSQL world, you actually want to move towards denormalization where it makes sense. And we'll talk a little later about more when it makes sense. But what would denormalization do for you? It would minimize your need for joins. You would reduce the number of indexes that you have to have because the data is housed next to each other. The data that makes sense to be next to each other is next to each other. It reduces the number of relationships. Remember, we talked at the beginning, relationships are hard, they're costly, they take effort. But the trade-off for that is now, if you want to update data, it gets a little harder. So if we go back to our same example, in a denormalized state, you can see we're storing active, inactive, monster, block group in next to the data. And if we wanted to change inactive now to closed, we have to go update every row in the database that has that, or every document in the NoSQL database that has that status as inactive. The trade-off is when we pull this data, you don't have to go to another table, you don't have to do a lookup, it's much faster. Obviously, this is a very simple example, but as you're, if you've done any work with a relational database that has many, many joins, those can get very slow as that object graph gets more difficult, especially when you have that impedance mismatch between what your data in your application looks like versus how it's ripped apart and stored in various tables throughout your NoSQL database. The next thing I want to look at is keying and how you might want to key your data in a NoSQL database. You don't have to think about this much in a traditional database because you're not necessarily worried about how your data is keyed. It's GUID or you just want uniqueness. But in a NoSQL database, whenever possible, you want to do something like a predictable key. So a predictable key is something that you're going to know either from the user or is known to the world out there. So an email address, a username, a SKU, an ISBN, a VIN number, anything that's predictable, because when they come in now to get that document, all you have to know is that predictable key, and then you can build up your document string and go get that data very quickly. So it's just one little get to go get that data. So this, to me, is the best type of key you want to use whenever possible in a NoSQL database, is a key that's a predictable key. Now, what if you can't use that predictable key, or it's not always known what that is? Then you can use the counter ID pattern. So this is the idea. It's very similar to identity columns in in a relational database. You'll take and you'll have an atomic counter, something that you increment, and then you're just incrementing that and then saving the doc ID as that. And that allows you to do things like, oh, the next one is, it's predictably 1001 if you're at 1000. If you know what that atomic counter is, you can get the next one or the last one. So in certain situations, that might be even a more efficient key than a predictable key, because you're really only ever getting, the next comment, or you're only getting the last 10 comments, maybe for a blog or whatever. So your use case might really make a counter ID pattern really a handy IDing pattern to look at. The next I want to talk about for keying is the lookup pattern. And the lookup pattern, it kind of combines both. So there's many cases where you might have more than one predictable key. You might have their their email address and their Facebook login and a couple of different things. So you can create documents that have are just like a lookup document to point to the primary document. So you'll have your primary document, maybe it's using a GUID, and you're storing that. And then when you want to look up that document, it's just a double get. So first you get by the predictable key or whatever, and then you get the document. And that document is just going to return the pointer to the primary document, which has the data maybe that you're looking for. And you can build up then lots of these little lookup documents for the many ways that you might want to get your data. And these double gets is way more efficient than a query would be in a relational database or even against a NoSQL database. So a little example of what that might look like in a relational database, you know, if we're going to just insert some data, so we might insert the guy's name, his Facebook ID, his email when it was created into the database. And then if we want to query for that, we're going to get the user by his Facebook ID or get the user by email. The issue with that is over time, obviously in this very simple pattern, over time, it's not going to change the query much. But, you know, if this was a more complex example with many joins, that would become much, much harder. So the way we could solve this problem with NoSQL is, again, we're going to use our counter ID pattern. So we get the counter, the user counter, and we're inserting the next data, the primary document, with that counter. And then we're also inserting our two lookup documents, so both by the email and the Facebook. So when we want to get that, we just use our double get pattern, get it by the Facebook and then get ID and then get the user data, or get it by the email and get the user data. And those return very fast. We'll talk a little bit later, like gets and sets in NoSQL database are fast. So the next thing I want to talk about, besides keying and how that is different in a NoSQL database, is embedding and linking documents and data. So what's this concept of embedding? So anything that's accessed frequently to related data, you'll want to embed right in the document. So imagine you have a friends list on a user, and every time you're displaying the user, you're always displaying their friends, and you're displaying the friends, you know, avatar and their username and their password, or not their password, but their username and their first name and their last name. You'll want to keep that data right with the user. You keep all the data, not just the, you know, right now in a relational database, you might have a pointer to another user document and another related table. But you just embed all that data, the avatar, the first name, the last name, right in that user list. Again, it's back to that denormalization, but allows for that quick fetch. So when we're building the screens to display this user, it's one, very easy for the developer to get and build that screen because all the data he needs is there in one call. And two, it's extremely fast to get that data. So whenever possible, we want to use embedding. But there is some trade-offs, as always. This can cause data duplication. Obviously, if I'm a friend with like 70 people and my data is, my name and avatar and whatever is in each of those 70 people's user records, that's a lot of data duplication, and then becomes more difficult to update that, and it can become inconsistent over time. So again, it's about those trade-offs, using what you want to do depending on your use case. The next thing that you can do is this concept of linking. So instead of keeping the entire user document under that friends list in your primary document, you could do something like a link to those user documents and just keep that in an array. So instead of having the pointer to, or instead of including all the data, you just have the pointer or the key in that friends list, and then you just do a get on every document within that list. If you link data, it becomes a little easier to do updates. But there is no, remember, in a NoSQL database, we're trading a little bit that there's no referential integrity. So you'll need to make sure that if you update a key or you're deleting a document, that you also update or delete anything that you have linked to that document. So embedding versus linking, you want to embed when there's few or little updates to the data, when you cached or when it's very time to live sensitive. Otherwise, you'll want to use linking. And there's one other concept, and that is parent referencing. And so whenever you have a lot of data, so you're not gonna, let's say you're keeping a log of every time the user logs in to our little user system with his friends list. You don't want to keep a record of the log in the user object because he might log in, 20 times a day, or you might not want to track every click. So you can do what's called parent referencing. So in the document that is the log or the click log or whatever, you will store the key to the primary user document. And that looks very similar to how you might do it in a relational database. And you want to do that when there's little need to access all the user data, but there's lots of records. So my general rule of thumb is when you have one to few, you use embedding. When you have one to many, use linking. And when you have one to squillions, yes, squillions is a real word, you use parent referencing. So as you can see, when you're going through a NoSQL database, you're making a mental shift. You have to think differently than how you're maybe traditionally thinking about databases. For me, these are a couple things that I struggled with at first. I was used to, in a SQL relational data model, of avoiding hitting the database whenever possible. That was costly. We had connection pools to deal with. We didn't want to overload our servers. With a NoSQL database, gets and sets are fast. They're not a bottleneck. This is hard for many people to absorb at first, like to get it, but gets and sets are fast. I mean, they're like fast, like really, really fast. Gets and sets are fast. So there's this mental change that you can do gets and sets often in a NoSQL database that you weren't doing. You were trying to, batch all that up in a traditional SQL or relational database world. There's a couple other mental shifts I had to make. I had to kind of getting rid of that idea of third normal form. That took some getting used to for me. Thinking about data integrity, not having the database do that for me. And getting used to the fact that schema changes were easy. In traditional databases, right? If you're adding a column or changing a column name, that was very difficult. You had to go through maybe a lot of relationships and update them. You had to go through your code. Here, schema changes can be easy. Again, they're not applied at the database level, so you can make a schema change and then, have a V1 and a V2, and you just have your implied schemas for each version out there. So when to use and not use a NoSQL database? For me, there's two big drivers to using a NoSQL database. The first one is kind of why they were born, and that was companies like Amazon and Google had all this data, and it was getting too large to store in the normal systems, and they wanted to do lots of small servers with commodity hardware. So they built systems to that. But for me, the real reason is that a lot of times you have impedance mismatch between your data. So because of that, we build in NoSQL databases because it just gives us, the object is just the object. The order has all the data there. We don't have to go to the line item table and the product table. And it really makes developing and time to market much quicker if you're using a NoSQL database. But in reality, a lot of times you'll have polyglot persistence now. To me, this is best. I said at the beginning, use the right tool for the right job. Document DB when it's ready, relational DB when it makes sense, graph DB when possible. Each has their tool and each is the right tool for the right job. So just make sure you choose those wisely. If you're looking for more information on this, there's a great workshop on NoSQL data modeling by Jan Steeman, Introduction to NoSQL by Martin Fowler, who's awesome. And there's a couple of blogs that I posted in there. If you're looking to get a hold of me, I blog at CKH Consulting. That's our company's blog. There's my Twitter, LinkedIn. I'm an avid Facebook or avid League of Legends player, not an avid Facebooker. So if you want to get a hold of me on League, that'd be great too. So that is my talk. Relationships are hard. Thank you.